Hello, welcome back. I do apologize, the video being in two parts. My class just started and Zoom crashed on me, so I had to do it in two parts. But I'll continue off where I left off in question number 24. So in question 24, we're looking at the draw the products of each one. So this guy right here is a Z product. That means it's going to be a cis. So, and it's going to be hexane, which means it's going to be 3 bonds, and it's going to be the third double bond's going to be on the third carbon. So it will look something close to 1, 2, 2, 3, 4, 5, 6, something close to this. What's going to happen is you're going to take this double bond goes away, and so it's going to basically form a positive negative charge. When the D splits, it's also going to form a positive negative charge. Both of the D molecules are going to attach to this guy right here. We get a D here, and you get a D compound here. So that's what this guy's going to look like. Well, I don't speak French, so I don't know how I can help with that. Sorry, I just got an email. Other chemistry tutors that speak French. That's usually a key thing. You can't do that. They speak English. Okay. So this compound right here is going to be considered a meso compound. The reason being here is, well, it's meso compound. Both the carbons are technically chiral, but it's a meso. It's meso because it is symmetrical. Here's what the molecule would look like if you do Lewis dot structure. Kind of looks like this, with a D coming off here and a D coming off here. So both these carbons are technically chiral, but since it is symmetrical, it is meso, meaning there's only one way to do it. So there is no chirality, there is no enantiomers and stuff like that. What E looks like, E is going to look like the same thing, except it's going to be long and kind of look like this, but a little bit different. So same thing is going to occur. We're going to get 1, 2, 1, 2, 1, 2, 3, 4. Oops, I'm just going to draw it like this. I'll just draw my way I do it. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And since it is trans, and it's not, it's not symmetrical, you're going to get a racemic mixture, which means you're going to get it like this. Second, the students ask me a question. Bing, wedge, 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 and that's what you would do. I'm missing some carbons there, but it's pretty much the general shape, and that's how you do 24. Here would be D molecules. D are treated like hydrogens, they're just not hydrogens. So you have to treat them like their own little thing. Okay, for 25, what 25 is asking, so 25 is trying to the boiling point. So the boiling point between double bonds and single bonds are relatively very close to each other. It's just the fact that single bonds tend to have a higher boiling point, slightly higher. We still want to know, though, that the more carbons you have, the higher your boiling point. So out of all of these carbons, the highest one is octane. Octane has the highest, which means it's going to be F. So I'm after taking this guy out. Up next, we have cycloheptane and heptene, teen and ane. So this guy right here is going to be a double bond. This guy here is going to be a single bond. which means these guys are also going to be your second highest. And the double bond one is going to be a little smaller than your big one. So D and E are taken care of. Hexane is always going to be pretty much B. Hexane is always 69 because it's a fun number. Cyclohexane, though, is going to have a higher version. It's a cyclic one. That's 70. And 1-hexene has a double bond. So that's going to be A. 1 second. Someone's having an episode. There we go. Okay, 26. 26 is a weird one. 26 is going to happen here is this guy right here is an anti-Markovnikov reaction, which means once this double bond right here breaks, the positive charge is going to go here, and the negative charge is going to go here. Remember, in anti-Markovnikov, it's the opposite of what normally occurs. Normally, positive charge want to be tertiary. But since it's anti-Markovnikov, we're going to switch that around and kind of make that a positive charge. So, good. Which means we're attaching OH to this guy right here. The OH, which I'll do in pink, the OH, the alcohol, is going to attach to this carbon right here. The H is going to come from this BH3, which is kind of like a proton donor, an acid, and donate there. So you're going to get this structure right here. Where you have the OH here, and you're going to have the methyl group. Now, if you notice right here, this guy right here is chiral. Same thing with this guy right here. It's chiral. So those are 2 chiral carbons, which means we're going to have to give them a racemic mixture. With anti-Markovnikov, we're going to give racemic mixtures. So let's if this guy's over here is a wedge. This guy right here is going to be a dash. And over here, it's a wedge. And over here, sorry, it's a dash. This guy right here is a wedge. And anti-Markovnikov just gives racemic mixtures most of the time. So, and that's what occurs. Okay. So we're going to complete the Newman projection and then draw the product. Our product is going to be a bulky base, which means we're going to add a double bond. Our eyeball is looking at this structure like this, right? So the bromine's going to go up like this, the hydrogen's going to go down. So we're going to put the hydrogen over here because on this side is where things are going away from us. You notice right here, the ethyl group's also kind of behind the other methyl group. So this is where the ethyl group comes into play. If you don't know what the ethyl group is, I'm talking about this guy right here. He goes there. The methyl group is going to be here because this is coming up at us, going up. This methyl group's also in the way too, so both methyl groups are like this. Good. If the bromine were to leave and the double bond were to occur, what's going to happen is you're going to get a double bond, right? You're going to get a double bond here. And because, I'm actually going to erase all this so you can see. The double bond leaves. Double bond leaves. You're going to positive charge here. This guy right here is going to steal a hydrogen. There's a hydrogen. Bond here, double bond forms there. And the ethyl group is going to go down, right? Because we're saying the ethyl group's gone away. And then the methyl groups are coming up. And then the hydrogen's going to come down. Because these guys are staying near, these guys are sticking with each other. And these guys are sticking with each other. And that's how you would draw the product from the Newman projection. Over here in 28, same thing occurs, except now the bromine's going up, this is going down, and we're going to swap some things. still eyeballs here. Ethyl is still this way. But now the methyl is going to interact with this. Right, methyl over here. And the methyls are going to be over here with the hydrogen kind of right here as well. So there we go. So when we draw the double bond, it's the same thing. It's going to be a single line like this. But this time, the ethyl goes up with its hydrogen, or its methyl group. So this part right here is going up. And this part and this part is down here. Looks kind of like that. Okay, X structure. So I did this wrong last time, and I do admit, I do understand this concept way better now. So this guy will always form this guy right here was going to get rid of all double bonds, and it's going to form a achiral structure. Because there's no branching, right? Not a lot of branching out the double bonds. This forms when there's a double bond near a primary carbon. So since I have a whole other product right here, I know one of my double bonds is going to be right there. Because when this guy reacts, it's going to split this off and make that guy turn into this guy. The carboxylic acids right here and right around here are going to occur when a ring opens up. So if this whole methyl group appears, these two rings, this ring will go this way, open up that way, and this ring will open up this way and go that way. This leaves these 2 points right here where the carbons were connected. Those kind of split open, and now you get 2 lines. And now this guy, when it loses that, it's going to 1, that's 2, that's 3, 4, 5. 1, 2, 3, 4, 5. There you go. Kind of like that. Similar thing. I just kind of flipped over a little bit. So, like that's occurring. Here's where the rings used to connect, right here and right here. Those are going to turn into that. So the double bond has to be somewhat similar to that, right? So that makes sense. It is this guy right here that I care about. He's in what the second double bond is. Since he is nowhere near that, this guy right here tells me there's a double bond with 3 carbons away from either opening. So 1, 2, 3. 1, 2, 3. So this guy right here is what a second double bond does because it forms that guy. So what it looks like, or what the structure is going to look like, it's going to look like this. Double bond here and double bond here. Like I said, the red one happens, it explains why the double bond is here on this methyl group right here, because it's going to help it split off and form this guy. The double bond down there helps explain this middle guy right here. And that's how you do 29. 30 is the same concept. So notice we have a new product right here. So it's got to split off. So you notice all of these guys have a little guy right here, and a little guy right here, and a little guy right here, and right here, and right here. So all of it makes sense. That's all good. We want all that stuff. Okay, good. If you notice then, I also only have one little O guy right here, which means I only have 2 bonds. So I can get rid of all of them with to have 3 bonds. That eliminates C and B, because if I had C or B, I would have 2 bonds there. Good. Next, I got to figure out where these guys are located, these little openings of the ring. Hello. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll be 9 away from the one that popped off. So it'll be 1, 2, 3, 4, 5, 6. This guy is 6 away. So that's wrong. Right? So it'll be 1, 2, 3, 4, 5, 6. Nope. So between A and E. We want the ring to open up right here. I want that ring to open up right there. So because we have 2 of those, one right here and one right there, it's going to be E is the answer, because with E, what's going to happen is when the chemical equation reacts, the bond, this bond right here is going to break off, causing it to occur right there. There we go. Sorry, I'm going to sneeze real quick. Okay. Number 31 is a bullshit question. You just need to know that if you have this guy right here, you would have formed a triangle. It's just what you have to know. So bromine leads, as it does, this is going to form a double bond. So what the structure is going to look like is it's going to look like this. That's what KT butyl does. Both iodines leave this group right here. So now this guy right here is technically CH2 plus, and it's going to interact with both of these carbons. Both of these carbons right here to form bonds with this guy and need a weird triangle. It's just something you need to know. I don't know why he wants you guys to know this, but that's what you just have to know. So this new triangle thing right here is not a wedge, it's a triangle that comes from this guy right here. Okay, I think 32 and 33 are the most important questions out of the entire problem set, because if you look at this, it tells you exactly what's going to happen. So we have this guy right here, he's cis, and he has no branching, which means when this guy occurs right here, it's going to form an achiral carbon. So it's just going to form the same thing. I'll use black instead. I'll form an achiral carbon. That's just like that. Good. This guy right here. One carbon, it's a mesocarbon. 1 second, someone's calling my name. Okay. It is a mesocarbon. So since it's meso, it's going to have both. Whoops, that's not put meso there. I'm going to put OH. This guy right here makes an OH molecule where the double bonds are located. Who would be? But it's meso because it has a line of symmetry. So it's meso. What's going to occur over here is you're going to, oops, I went to be black. Right around here, we're going to have racemic mixture. So we're going to have bromine, 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 bromine. I draw it like this, you guys can see, but in reality, the molecule is actually going to twist a little bit, so it actually can form. So it actually would twist just a little bit, kind of form like this. So it actually would look like this. This, what I'm drawing down here, is actually the best answer because it's not racemic. Sorry, it's not meso. It's racemic. So there we go. So I actually would prefer you guys put this as a test answer. I just drew it like this to make it easy. Because this would be meso compounds, which is not true. It would actually look like the stuff down below. I just twist the carbon a little bit so it would not be meso. It's a racemic mixture. The same thing occurs with this guy down here. I'm drawing what I draw them as, but same thing. It's a racemic mixture. Racemic mixture. Racemic mixture. OH. OH. Oh, sorry, typically should be dashes. Dash, 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 dash. OH. OH. We're just going to flip them around a little bit so they're not technically meso or racemic. So you're drawing like this. Okay, that's how you do 32. And you notice that's a cis molecule. Here's a trans molecule. So the things are a little bit different from each other, right? For cis molecules, right, Br2 forms 2 products. Over here, Br2 forms 1. The CH3, CO2, that one right there, the bottom one, only forms one molecule. Well, this guy right here forms two. So the system trends are a bit different. Again, you form an achiral mixture, nothing occurs here. You're going to get a sorry, someone keeps on texting me. 1 second. Okay, I'm back. Sorry about that. You're going to get a meso compound here with bromine. You're going to get a meso compound up here with the OHs. And you're going to get a racemic mixture down here. But yeah, that's how you would do the alkene review. I'm going to post practice quizzes today, hopefully, but that's it. Thank you very much. Okay.